Greetings, math enthusiasts! If the world of numbers has you feeling like you're lost in a labyrinth, worry not, for I am your guide through the mathematical maze. This is Margaret Jude Royal, your master in service. Get ready to embark on a journey into the second quarter, pencil and paper in hand. Special thanks to the Department of Education in the Cordillera Administrative Region for equipping learners all across the Philippines with quality self-learning modules. By the end of this episode, you will be wielding the power to define, illustrate, find zeros, understand left and right hand behavior, describe the graph's relationship with the x-axis, and master the art of sketching and interpreting polynomial functions. But before we dive into our lesson's depths, let us first know what a polynomial function is all about. In illustrating polynomial functions, it is important to bear in mind what is currently shown on your screen. Let us warm up our mathematical muscles. How can we distinguish a polynomial function from its numerical counterparts? From the definition that was presented earlier, we can keep these three golden rules in mind. Now, let's apply this new knowledge by classifying each function as polynomial or not to complete the table. The functions that are highlighted in green abide by the rules of identifying polynomials. As you can see, each exponent of the function is a whole number. The denominator contains no variables in x, and no variable is under the radical sign. Therefore, they are polynomial functions. Meanwhile, these which are highlighted in red are the exact opposite. P of x equals 3 over x and f of x equals 5 minus 4 over x squared is not a polynomial function because the denominator contains a variable in x. F of x equals 9 times the square root of x plus 2x is not a polynomial function because it has a variable under its radical sign. P of x equals x raised to 1/2 plus 2 is also not a polynomial function because its exponent is not a whole number but a fraction. On the other hand, the leading coefficient is the coefficient of the term with the highest power of the variable, which means it is the term with the highest degree. For example, in the polynomial x raised to 4 minus 1/8x, the leading coefficient is 4, as it corresponds to the term with the highest power of x, which is x raised to 4. The leading coefficient is significant because it influences the direction in which the graph of the polynomial opens. To further understand the relation of the degree and the leading coefficient to the end behavior of graphs, let us observe these figures to complete the following table. In the first polynomial function, the degree is 3, an odd number, the leading coefficient is 1, a positive integer, and as you can see, the graph falls to the left and rises to the right. In the second polynomial function, the degree is 4, which is even, the leading coefficient is 1, which is positive, and the graph rises both to the left and the right. In the third polynomial function, the degree is 5, the leading coefficient is -1, and the graph rises to the left and falls to the right. In the fourth polynomial function, the degree is 4, an even number, and the leading coefficient is -1, a negative integer, which means the graph falls both to the left and the right. With these observations, we can conclude that the degree and the leading coefficient of the polynomial functions determine the end behavior of the graph. This is called the leading coefficient test, and to better grasp its essence, here is a table to help you visualize the behavior of the graph according to its degree and leading coefficient. Before we proceed to the next part, let us keep in mind this concept of defining zeros of a polynomial function, which will help us later as we go further in our lesson. At this juncture, you will have to ready your pen and graphing papers. Using the concepts that we have learned earlier, it is now time for us to sketch the graph of polynomial functions. Are you ready? If so, then let's go. For this example, we have the polynomial f of x equals x cubed minus 12x squared plus 44x minus 48 in standard form. Step 1. Determine the degree and leading coefficient. Step 2. Find the x-intercepts. Step 3. Use the rational root theorem to identify potential rational roots. Step 4. Apply synthetic division to test each potential root found in Step 3. Step 5. Substitute x equals 0 into the polynomial to find the y-intercept. Step 6. Plot key points on the graph and connect them smoothly to form the graph of the polynomial. Well done, learners! You made it until the end of our lesson. For our next video, we will be solving problems using polynomial functions. Once again, I am your master, Margaret Jude Royo. For more educational content, don't forget to like, share, and subscribe to our YouTube channel. See you next time! Bye!